Hello, everyone. I know it's the end of the day and everyone is rushing and looking forward to the after party. We as well. But our presentation will take almost like 20 minutes, so just bear with us. We're not going to be that boring, I promise. Okay, we'll try to be fast. So, for starters, my name is Merihan Hazem Bishara, and this is my twin, Meriam Hazem Bishara, longest two names. Yeah, and we're from Egypt. We're from Egypt, and today we will be talking about testing the untestable, metamorphic testing for complex and non-deterministic systems. And we will also talk about digital twin, how it can help verify what we cannot predict. So here, the main problem here that there are systems that are really hard to test. Like many of them, the expected output is not really actually reliable or really available. So that's the main problem here. This is the main point of the issue. And here we have the test oracle. It's actually it serves like a mechanism which can recognize any issues during the software testing. So we can say that it somehow can help us detect any incorrect behavior in the system, since it cannot actually detect any correct behavior in the system anyways. So let's just give us a small example here, like image classification. Suppose there's a classifier model that its job is to classify the name of the animals, images of animals. So we're going to input an image of a cat, and the expected output would be that label of a cat. But the question here is this output actually will be possible for every input image, for every image we input? Like next slide here. This is just a simple image of a cat. Here we have also images of cat, but as you see, they're different. There's a cook, investigator, whatever. So for every possible image we input, will the output be correct? Like we will have also the name cat? Figures. So what could be the solution here? We have either, like, we can actually try and predict the output. So for this solution, we have two options. First, we can either hire a fortune teller that can predict, but I don't know, crystal ball and all the effort, it's quite pricey, and I myself don't prefer it. But we have also a better solution, which I highly recommend, which is metamorphic testing. So, despite the crystal ball and our fortune teller, metamorphic testing is actually a better option. So the idea of the metamorphic testing, that it can actually predict the output. So, for example, like my sister mentioned, the state of the problem, like there's not always accurate outcomes or accurate outputs. So the main idea here is that this test technique is used when we don't know the exact correct answer. So instead of just checking the exact output, we can actually predict, sorry, I just got nervous for a second. So yeah, instead of like when we're inputting the data, we make some small changes into the input, and according to that, we can predict the output. Okay, so when we're thinking of metamorphic testing, what do? We have something called metamorphic relations. Metamorphic relations here is that when we do some transformations or changes to the input that we're inputting. So when we do that, for example, like the image of the cat again, so let's make some changes to the same image of the cat. Let's say we will do some rotation, 10 degrees, or we're going to play with the brightness of the image a bit. Or for example, if we crop the picture, like only half or only part of the cat is appearing. Or we play with the symmetry, like for example, we have images A and B. Both of them are cats, but they just look different. So the model should still predict that both of them are cats. So another example, machine translation example. So let's just say that I'm having, like, the input would be, I want to input an English sentence, and the expected output would be, it should be translated into French, correct output. Let me demonstrate. So imagine a fine, wise English gentleman would look at the weather in the morning and would say, oh, the weather is nice today. And expected French translation, s'il vous plaît, mademoiselle, il fait beau aujourd'hui. Exactly, thank you. So the change here is that if we add metamorphic relations, first of all, if I want to say, the weather is nice today, instead of nice, I will say pleasant. So the expected output would be that the same English sentence here, just a small change with it. The correct French translation would be the same. Also, round-trip translation. I want to translate from English to French, and then the same French sentence to English. It should be also, the output should be correct. Expect output should be correct. Yeah, so here we have a practical oracle, which is called digital twin. Despite that we're actually twins. Yeah. We actually chose this part because we're twins, honestly. So, what is digital twin? It's actually a virtual model of the real system, and of course it has to be up to date with the real world data that we have. So we can use it in order to monitor and analyze and also try and predict how the real system will behave. So, take it from someone who knows, not every twin is identical. We're identical twins, but we're not exactly the same.
We're not 100% the same.
Like we can play spot, sorry to interrupt you, we can play spot the differences game after this presentation to prove it. We're not practically identical.
So, a digital twin is not an exact copy of the system, but it can be used in order to simplify the reality. Like instead, it acts like a proxy. So it can use the data and the models that we have in order to predict the outcomes. So we can say that it's acting as if something that will help us answer the what-if questions that we have and try to make decisions towards it. For example, we have an example of a bicycle. For example, we have a real bicycle and digital twin bicycle. So, of course, they'll not be exactly the same, but the digital twin bicycle, it will somehow help in order to give us some info. Like, for example, it will at least predict how fast it can go if we change the gear, or, for example, how the brakes will wear out, or, for example, if we need to pedal uphill, then how much energy it will be needed. So we can just say that, it's a very useful guide, and it just acts as something that it can help us in order to make decisions instead of just a flawless mirror. So I would say, magic mirror on the wall. What's the flawless test of them all?
Small
I
drama.
believe all of you know this sentence. So we talked about metamorphic testing and digital twin. So how can we mix both of them together?
Maybe, let's think, by applying both of them together, both metamorphic testing and digital twin together. Although it will never give an absolute correctness of the output, but at least it will help us to reveal some hidden flaws that's not visible. Even if we don't have any ground proof.
So, how can we put them together? First of all, we bring the real system and the digital twin system, and we try to make some transformations to both of them. The same transformation we perform for both of them. And then we have to monitor and analyze it, and if both respond in a predictable output consistently, then that's a pass.
But if their behavior mismatch, then that means the test oracle is trying to give us some hints that something needs to be investigated. There's an issue that needs to be monitored or analyzed. So, for example, let's give a small example regarding combining both together, metamorphic testing and digital twin. So, financial risk engine. Imagine, we have a bank that has a real-time risk engine, and its job is to calculate portfolio exposure. So in order for them to improve their resilience, they built a digital twin of this engine that's running under the same algorithm. It's the same engine, but it's like a test environment for them. Stuck? Sorry. Okay, so steps of applying them. So let's imagine we have both real system and its digital twin. We need to insert in input. So we're going to input a set of trades, let's say 10 trades, Euro-USD currency pair. We're inputting it into both the real system and its digital twin. That's something. Then we want to apply the metamorphic testing technique. So we are going to add or like input the same set of traits, but the only difference is that we're shuffling these set of traits. They will not be in the same order. Next.
So here, after we ran the transformed input for both of them, the real engine and the digital twin, we're gonna analyze and monitor the output. So if both of those systems, they preserve the exposure values in a consistent way, then it's a pass. But unfortunately, if either of those systems produce any order-sensitive results, then it's a fail. So in this case, it's showing like, okay, there's a problem, like either some kind of error or concurrency issue or something like that.
So the main thing here is that we're not asking or like thinking if the output is correct. No, we're at least thinking like when we have or input these transformations to both real system and the digital twin, will the output be correct or as expected or not? Will they actually have the correct behavior or not? That's the main thing we're thinking of. That's not included in our time, okay?
Yeah, so let's wrap it up. Not the shawarma, guys, I'm sorry. We'll just wrap the presentation for you. The shawarma is for the cat, sorry.
Sorry, but promise you, maybe one time we'll invite you to Egyptian shawarma, promise. Another time. So, eventually to wrap this topic up, two main things. Differential metamorphic testing, where we compare both real system and its digital twin under transformations, under metamorphic transformations. We can spot drift, diversions, and also regression across versions. Second thing, digital twin as a test harness, which helps us to separate out non-deterministic factors like system load and all this stuff. At the same time, it helps us to make the hidden flaws more visible for us to see, especially under unusual conditions. Thank you. This slide is done.
Okay, so closing thoughts before we say goodbye.
Two kids in saying goodbye, but before we say goodbye.
So here, eventually, metamorphic testing, it actually allows the testing even when most of the exact answers are unknown. But we have to apply the correct patterns and relationships. And digital twin is actually strengthens this approach because it's actually acting as a useful guide in order to actually make at least a couple of decisions, even if it's not 100% correct, but at least from 80 to 90% correct. So even the unpredictable systems, they can show consistent issues, but that is if only we examined it in a correct perspective. So, goodbye.
Goodbye.
Thank you.